Alright, this lesson is about using Pascal's triangle to expand a binomial when it's written to a power. So remember, if we did not have Pascal's triangle to help us as a shortcut, x plus y to the fifth power, we would have to go x plus y times x plus y times x plus y times x plus y times x plus y. And we'd have to multiply these and take that result and multiply, and that would get bigger when we multiply again. Just setting up the problem was exhausting. So luckily Pascal gave us a better way. Now Pascal's triangle, and so this is something you can generate on your own anytime you want. Very convenient, travel sized. It starts off with a small triangle of ones. 1, 1, 1. So the rest of the process is you take two numbers and you add them together and you put the result in the middle, like that. Okay? Then on the ends, you're always going to have ones. So 1, 1. Now repeat. If I take these two, add them up, I get 3. 2 plus 1, another 3. Okay? Finish it off with ones on either end. Alright, add these up, I get 4. 3 plus 3 is 6. 3 plus 1 again is 4. Okay, put your ones on the end. Alright, I'll do one more, but you could keep going and going and going. 1 plus 4 is 5. Add these, you get 10. 6 plus 4, another 10. 4 plus 1 is back to 5. Put your ones on the end. Now, what does this have to do with binomial expansion? Simple. Well, we know that anything to the 0 power is 1. So it makes sense that this first row gives us the 0 power. Now, we will just increase the exponent from here. So it's going to turn out that all of these yellow numbers are the coefficients of a polynomial. Alright? So these will turn out to be the coefficients of the polynomial, the binomial, that you would get if you did x plus y to the 1 power. And these are the coefficients that you would get if you did x plus y squared. These are the coefficients you would get if you did x plus y to the 3rd power, and so on. X plus y to the 4th power, and x plus y to the 5th power. And it would keep working. You go as far as you want, 6th power, 7th power, whatever you want to do. Okay, so all you have to do is decide which one of these rows you're going to use, and then use it. So in this particular case, since we're doing x plus y to the 5th power, then that means we are interested in this row right here. Okay, so that means we will have these coefficients 1, 5, 10, 10, 5, 1. So rather than having to do the entire problem, we can just start with already knowing the coefficients. Okay, we can start with 1, 5, 10, 10, 5, 1. And they always start off positive, so just put pluses on everything. After that, since we have x here on the left, we're going to start off with x's on the left. And we will use the degree of the problem, so x to the 5th power to start off with. And then we will decrease the degree as we go. So it will then be x to the 4th power, x to the 3rd power, x squared, and just x. And then the last one gets 0 x's. And then we will switch over to the y's. Okay, the y is on the right, so we will start on the right. Again, we start with the degree of 5, so we start with y to the 5th power. And we will go to the left, decreasing the power each time. So we will have y to the 4th power, y to the 3rd power, y squared, just y, and the last one doesn't get any y's. Alright, now for this particular problem, we really are finished. This is the answer. We have expanded x plus y very quickly with the help of Pascal's triangle. The only thing I would fix about it is this leading coefficient of 1. We would not write 1x to the 5th power. We'll just put x to the 5th power. Similarly, we won't write 1y to the 5th power. We'll just put y to the 5th power. Now it's perfect. Alright, moving on to the next one, number 8. Okay, so instead of having a y, we have this 4, and it's negative. So let's see how that affects the process. So first of all, 4th power. So let's look at our Pascal's triangle. So this time we are interested in this row of coefficients. Okay, because this is the one for the degree 4 polynomial. So 1, 4, 6, 4, 1. Okay, 1, 4, 6, 4, 1. Notice how I space these out. There's going to be a lot going on in between these numbers, so you're going to want to space them out as far as you can fit them, and start them off with pluses. Okay, if you get it too squished together, you're not going to be able to read what you're doing, nor will your teacher. Okay, let's start on the left with the x's. X to the 4th power, because that's the degree of the whole problem. So we start off with x to the 4th power. Then we decrease from left to right. So this will be x to the 3rd power, x squared, and x, this one doesn't get any. Alright, now this is negative 4. Not just 4, but negative 4. We will start on the right since this one is on the right. So we have our negative 4, and that's to the 4th power. And then as we go to the left, we will decrease. So notice how I'm using parentheses around my negative 4. You do that too. So this will be negative 4 to the 3rd power, negative 4 squared, and this one will just be negative 4. Alright, now all of these powers of negative 4 need to be evaluated. And if I were you, I would do that first before doing anything else. Now be careful. If you do a negative 4, in fact, let's go to the blackboard. Okay, please understand this. If I take negative 4 and I square it, is that going to give me a 16 or a negative 16? That's going to give me a positive 16, alright? And you know this because a negative times a negative is a positive. So look, and maybe I'll just show that too. So because that's negative 4 times negative 4. If we take negative 4 and we cube it, alright, is this going to be a negative or a positive answer? This is going to be negative. Okay, this will be a negative 64. Alright, the reason why the negative stays around is because we have negative 4 times negative 4 times negative 4. Okay, a negative times a negative is a positive, positive 16, But then we still have this other negative 4 that has to be multiplied. And now you're back to a positive times a negative, which gives you a negative 64. Okay? So hopefully you get the idea here. So if I have negative 4 to the 4th power, that is going to give me a positive answer. And I think that's 256. Alright? And that's back to a positive. Again, that's because if I do negative 4 times negative 4 times negative 4 times negative 4, okay, I got 4 of them. A negative times a negative is a positive 16, and a negative times a negative is a positive 16. So I've got a positive times a positive is a positive, alright? They pair up, and all the negatives cancel out. I'll just go one more level here. If I have negative 4 to the 5th power, do you think this is going to be a positive or a negative? Okay, hopefully you see the pattern, and it's going to be a negative. Okay, and 4 to the 5th power is 1024. Okay, so that's going to be a negative 1024. Alright, so hopefully you can see that if you have an even power like 2 or 4, the when you do the power, the negative goes away and it becomes positive. But if you have an odd power, if you raise a negative number to an odd power, it stays negative. Okay, and hopefully you understand why that is. Now, one more thing to point out to you has to do with your calculator. Okay, take this for example, negative 4 to the 4th power. Okay, a lot of kids will do this, and it's, whoops, yeah, no, this is what I meant. If you do negative 4 to the 4th power, I'm claiming that if you raise negative 4 to the 4th power, you're going to get positive 256. So a lot of kids will do this. Let's move that over. And go, okay, negative 4 to the 4th power. And they'll go, wait a minute, I thought you said this was going to be a positive 256. And here I'm getting negative 256. Actually, they don't even ask that question. They just copy down the negative number and get the wrong answer. Can you see what the problem is? Hopefully you understand about parentheses. For this to be accurate, you need to include that negative in parentheses. So if you're going to trust a calculator to think for you, which I don't recommend, then you have to make sure that that negative gets inside the parentheses. So you have to put negative 4 to the 4th power like this, and then you get the positive 256 that you expect. Alright, anyway, so like we said, this is going to turn out to be positive 1024. This is going to be negative 64. This is positive 16, and of course you've got the negative 4 there. So now we're ready to find the final answer. Okay, x to the 4th power, we don't need the 1 anymore, so we'll just put x to the 4th power. On this one, we've got 4 times negative 4. Got to multiply those together. So that's going to be a negative 16. And then we have our x to the 3rd power. Now we're here. Forget about the green and use the purple. So we're doing 6 times 16. Okay, I don't know that off the top of my head. So 6 times 16 is 96. Okay, and it's positive. All right, positive 16. So that's positive 96 x squared. Notice the blue part is not changing. X to the 4th power, x to the 3rd power, x squared. Nothing's happening to that. Okay, so now we're on this term. We've got 4 times 64. Okay, well, negative 64. So I know it's going to be negative something. Okay, 256. Alright, so negative 256x. And finally, a positive 1024. So that should be your final answer for number 8. Okay. All right. Pascal's triangle. So we have the third power. Let's go back to our Pascal's triangle for the coefficients. So this time, because it's degree 3, this is the row at which we will look. So the coefficients should be 1, 3, 3, 1. Alright, so let's start with that. 1, 3, 3, 1. See how far I space those out? You do the same. Start with positives. Okay, let's be real careful. So we're going to start with this 3x. Please, please put that 3x in parentheses for me. Like that. We're starting with the third power, so we'll have 3x to the third power. And then we will do 3x squared, and then we will do 3x, and the last one doesn't get any. Okay, now we will do the 1. Okay, it's on the right, so we're going to start off on the right. 1 to the third power, and then 1 squared, and then just 1. So now it's time to evaluate. Alright, this time we will have to evaluate the 3x to the third power and squared, as well as evaluating the 1s. So let's go ahead and do that. Alright, now the key is when you do 3x to the third power, you've got to do 3 to the third power and x to the third power. Alright, without the parentheses especially, some kids will just write, oh, that's going to be 3x to the third power. No, you have to do 3 to the third power. That's going to be 27. Okay, so I'm going to have 27x to the third power from this. If I do 3x squared, I have to do 3 squared and x squared. So that's going to be 9x squared. Okay, and then of course the 3x doesn't have a power on it. So that'll just be 3x. Now please understand that 1 to the third power is just 1, 1 squared is just 1. So all of these 1s aren't changing anything. Okay, so multiplying by 1, things stay the same. So I can really erase the 1s and just deal with this. Alright, so the coefficients. So I've got 1 times, I'm going to erase this 1 as well. Okay, so what I've still got to deal with these coefficients. Alright, I've got 3 times 9. I've got 3 times 3. This is multiplication. And I couldn't erase this one because it's the only thing in its term. So now I'm ready to do the final answer. So this will be 27x to the third power. 3 times 9 is 27. Okay, x squared. Alright, 3 times 3 is 9. So 9x. And then just bring down this 1. So this will be the final answer for number 9. Okay, and finally number 10. Alright, again we're doing the third power. So we're going to use the same coefficients as we did over here. So we're still dealing with 1, 3, 3, 1. Alright, still third power. So spread them out, people. So 1, 3, 3, 1. Let them start off positive. Okay, so on the left, we're going to start off with our x squared. So we're going to have x squared to the third power. Alright, and then x squared squared. And then x squared, to the 1 power, or just plain, and the last one doesn't get any. Okay, and then now we're going to do the 2. The 2 is on the right, so we start on the right. So we start off with 2 to the third power, and then 2 squared, and then just plain old 2. Okay, and the last one doesn't get any. Okay, let's see what we got. So for right now, I'm just going to recopy all of my coefficients. So the red part, I have 1 and 3 and 3 and 1. Now for the blue part, x squared to the third power, you know that I'm going to multiply these. So this is going to be x to the 6th power. Alright, a power to a power you multiply. And this is going to be x to the 4th power. And then I'll just bring down my x squared. So that's all my blue part. Now I'm going to do all the green part. This one doesn't have a power, so I'm just going to bring down the 2. Alright, but 2 squared is 4, and 2 to the third power is 8. Okay? I always like to do all the powers first, and then I come back and do all the multiplication. The reason why, I'm following the order of operations. Exponents come before multiplication. So do not get messed up and sit here and do 3 times 2 first, and then get 6, and then square that and come up with 36. That's wrong. You have to do your powers first. So I do all my powers first, and then I go back and do all my multiplication. So be like me, people, is what I'm saying. So this term just turns out to be x to the 6th power. Alright, this term is going to be, well, 3 times 2 is 6, so that'll be 6x to the 4th power. 3 times 4 is 12, so that'll be 12x squared. And then 1 times 8 is 8. So this will be the final answer for number 10. Okay, I hope that was helpful, and I will see you on the next video.